whole syllabus we have divided into 13 chapters. Okay, maybe like your college syllabus is exactly same, but they might have divided it into 6 units or 5 units, whatever. So I have done 13 different chapters. Like first chapter, directly we won't be starting with C programming. In first chapter, we'll be discussing about what is problem solving, what are different steps of problem solving, and then different ways of solving problem like algorithm, flow charts, pseudocode. Then we'll take some examples on it so that you get used to writing flowcharts and pseudocodes and algorithms, their advantages, all that. Okay. Then chapter 2 will be discussing about what is programming language, then what are different classifications of programming language like first generation language, second generation, third generation. Okay. And then what is a compiler, interpreter, difference between a compiler and interpreter, all that we'll learn. Then we'll be starting with actual C programming. Getting? So in the third chapter we'll discuss about history of C, then first C program, then what are different steps in running that entire C program, internal, all that chain or tool chain I'll tell you. Don't worry, each and every step of running a C program and what intermediate results you get, all that I'll show you also. That complete tool chain I'll show you. So in the first, this introduction to C, simple history, ancestor languages of C, then first C program, then what are different steps of running that C program, all we'll discuss. Then we'll be starting with elementary C programming, like what are keywords, identifiers, operators, different data types. Okay, so all that in chapter 4. Then input output, how to accept value from user, how to display that value on the monitor. Then there are different ways for accepting input output. C has given lot of ways: accepting single character, then accepting string, accepting different formatted data. All that in 5th chapter I'll cover. Then comes the main heart of every programming language, because maximum problems which we are going to solve using C programming are solved using control structures in which decision making will come. Getting? Like if else, switch case, then repetition code like loops and all. Okay, so for loop is there, while loop is there. So abundant of questions will solve, don't worry. Okay, I'll be taking lot of trace output questions. Timely I'll be giving you some multiple choice test to make you very much comfortable with this programming language. Then comes procedural programming. Okay, how we can divide our bigger problem into smaller problem, and for each small problem we'll be writing functions, and how writing functions will make code writing, it will give you the benefit of writing code. So what are the advantages of writing functions? Okay, what are different ways of passing values to it, all that we'll discuss. Then comes arrays. Okay, arrays means collection of values of same type. So when you create a group of values of same type, it makes an array. Then different operations on arrays, we'll be discussing about matrices and all. Okay, then different operations on matrix, and all that matrix operations will write a program for it. Okay, then a very fascinating feature of C programming, many people today also, after so many years of software work, they're still afraid of the terminology called pointer, which is actually not needed to do. It's quite easy concept. And what are the benefits of pointer and practical applications, like using pointers, how you can create viruses, and using pointer only how viruses can be removed also. All that discussions will do, don't worry. Okay, so pointer is the 9th chapter. Then comes strings. Okay, the string is like an array only, but it is just a sequence of characters. Only character array makes a string. So different operations on string, like joining two string, finding length of a string, reversing a string, converting it to uppercase, lowercase. For all that, ready-made library functions C language has provided. So all that functions we'll discuss. Then the same thing we will also try to develop. Okay. Then another important feature of C, that is structure and union. For time being, you can just remember, like array is a collection of same type. So structure is a collection of dissimilar type. Means when we have dissimilar values group, we call it as a structure. Getting? So that we'll discuss. File handling. No language is complete without file handling. Getting? Nearly all language. You learn Python, you learn C++, you learn Java. Everywhere you have to deal with file handling. And using file handling, you can develop some good mini projects and all. I'll give you some demonstrations of it. Okay. And one last important feature, that is C preprocessor. Okay. So in C preprocessor, different C preprocessors are there, like hash include, hash define, hash if, hash elif, undef, pragma. So many things are there. And what are their uses? All that we'll discuss later. Getting? So this way, entire C programming I have just divided into 13 chapters, and all this one by one will discuss. I'm sure you all are excited to learn all these things. Okay, just follow whatever is being taught, be regular, be in sequence. Whatever is done, just go through it every day, and after end of each chapter, I'll be giving you abundant of multiple choice questions for your practice. Okay, I'll give you some assignments also in PDF form. Try to solve it. Many assignments we will also solve. Okay, I'll give you hands-on of solving exercises, and some exercises for you people also. Getting? So at the end, I'm sure you'll be confident on C language, and maximum interviews. Getting? When you go as a fresher, all interviewers first ask, do you know C programming? Getting? It's called as mother of all programming language. No one is told to, no one can be said as a software programmer if that person has not learned C language. So C is a foundation of all programming languages. You should learn C programming. Getting? So I hope the outline is clear to you, so that we can start with the actual syllabus. Okay? So just give me the confirmation if the outline is clear. If you have doubt in this topics, you can ask me. Okay? You people can invite your friends also from your different colleges, or all your 10th, 12th friends, those who have gone now for engineering. You can please invite them for few lectures. You can tell them to attend few lectures of C. Then they can decide. Decision is their part, but they can attend few lectures. Okay. So I'll be happy to see many more students. Okay. Now we'll start with the actual syllabus. Okay. So chapter topics list is clear to you. We'll start with the first chapter, that is problem solving using computers. Okay. So in problem solving, we'll be discussing about what is problem solving, what are different steps of problem solving, then different ways of doing problem solving. So there are three ways. One is writing an algorithm using simple English. Second is flowchart, and third is pseudocode. So all three I'll tell you. We'll take some ample exercises on all three, their advantages, disadvantages also. Okay, so that will be in the first chapter, right? Now first we'll discuss about what is problem. Now from your side, I want some responses. What do you people think a problem is? Just in common sense, what you people think, what is a problem? No? Obstacle. Very good. Okay. Very good. What he said, Astik is saying an obstacle. hurdle. You can say it's a hurdle or obstacle. That obstacle is not allowing us to reach to the goal, right? Our goal is something, or we want to achieve something, or there is some goal and we want to uh, get that goal, and we are not able to get it. So there is some obstacle or an hurdle which is not allowing us to get that goal. Okay, the obstacle, what others say, there should be an interaction, no? There should be participation of all. Okay, I know the time is too early, but now I hope you all have grown up. 7:30 is okay, right? No, what others say, Astik is saying obstacle. What about others? What do you think? Nishchay, Rishabh, Prishita, what you can call a problem is? Same, you agree with him. You can call it as an obstacle, an hurdle. Okay, you can even say it is an issue, or it is some condition, right? Or it is some situation which we are not able to achieve. We will be achieving it, but at this moment we are not able to achieve, therefore we are calling it as problem. And once we achieve it, we'll say the problem is solved, isn't it? Many situations. Taking a very simple example, like my problem is I'm given two numbers and just I want to find out maximum of it. Getting? I want to find which is the largest one. Okay, or I'm given with three numbers and then I want to find out the largest of it. I'm given with n numbers and then I want to find out largest of it. Or I'm given with n numbers and I'm told to arrange them in some order, increasing order, decreasing order. Getting? So many situations can be there, so many conditions can be there, and that thing I want to achieve it. To achieve it, we will do it using problem solving. Getting? So till we are not achieving it, it is a problem, isn't it? Right? You're given with principal amount, rate of interest, number of years, and then they tell you to find out compound interest. Getting? So there is a formula, but using that formula, when you'll put your values in the formula, you'll get the result. So after getting the result, we'll say we have solved that hurdle. Getting? So you can say, what is a problem? A problem is an obstacle. Very appropriate word Astik has used. So you can say a problem is an obstacle which makes it difficult to achieve our goal or our objective. Whatever our objective is. My objective is I want to arrange all that numbers in increasing order, or I want to arrange all that numbers in decreasing order. Right? So that is my objective. And I am being told that these are the numbers and arrange them. So at this moment I am not able to arrange. Therefore, I'll say that I am not able to reach to the goal or objective. Therefore, it's a problem. But once I find out some solution to arrange them, then I'll say I have achieved my goal, means I have solved the problem, isn't it? So you can say like a problem, it's a situation or it's a condition or it's some issue which is yet to be solved, means it is yet unresolved. So once it is resolved, we'll say the problem is solved. So many problems are there. Getting? Our real life is also made up of problems, isn't it? Day to day, so many problems are there. In our entire real life also, we have so many problems. Some are very easy problems, some are intermediate level problems, some are complicated, some are very super complicated, and still we'll try to solve it. Every field is having problem, isn't it? Doctors have their problem, automobile engineers have their problem, computer engineers their problem, electrical engineers, they have their problem. So every domain is having different types of problems. Okay, then what you can call problem solving. So problem solving means achieving that goal, okay, or achieving that obstacle, clearing that obstacle, or achieving that objective. Getting? So once we are able to achieve our goal, we'll say our problem is solved, right? So trying to find out solution to the problem, we call it as problem solving. Correct? So I am being told to arrange the numbers in increasing or decreasing. So I'll find out different ways of doing. In computer science, there are abundant of ways to arrange numbers in increase or decreasing. You'll be learning this in your data structures subject. You'll have a separate, in engineering, you'll have one more subject called data structures. In data structures, you'll learn abundant of methods of arranging numbers in increasing, decreasing. The simple method is bubble sort, then you have selection sort, then divide and conquer, quick sort and merge sort. So many sorting strategies are there, and all strategies have their benefits, their advantages and disadvantages. So when you learn data structures, then you'll realize, see, our problem is only one, that is arranging number in increasing or decreasing, and they have found out so many different ways of arranging the numbers. Getting? So in short, what I wanted to say, that is finding the solution to the problem means problem solving. Getting? And problem solving is a very important part of your computer science. Getting? When you have entered in computer science, so obviously our goal is to find out solutions to different problems. Now some problems are there whose solutions are already been found by people, and you people are just learning that solutions. Getting? Like as you people now have entered in engineering, so you will be learning such subjects where you are not going to find the solution on your own. The solutions have been found, you're just going to understand that solution. But gradually when you'll reach to final year, so that time they will tell you to find out your own patent, or they'll say you submit your paper. So that time you are going to find out some unique way of finding out the solution to the problem. Correct? So when you'll reach to final year engineering, you will find out your own patent of some problem. Then you'll patent it in some magazines. Getting? So that time the solution is your solution. Now you people are just learning the old solutions, okay, and just understanding how those people have found out it. Clear? So problem solving is important day-to-day activity, and especially in the field of computers. Getting? Then what are different steps of problem solving? So this we will understand very properly. Okay, so all the problems which we are supposed to solve, ideally we are focusing only on computer related problem, because our subject is problem solving using computers. So I'll not take a day-to-day life problem. Getting? Like problem is making a tea. Okay, problem is whether to go to college or no, whether to go for birthday party. So there are so many problems. I will just try to focus on those problems which will be solving using computers. Getting? So if you want to solve any problem using computer, so you have to follow 4 important steps. Getting? First is understand the problem. First thing, you should know what the problem is. Like I told, the problem is arranging numbers in increasing or decreasing, which we call it as sorting. So first you should know what is sorting. Means what do you mean by sorting? Getting? So first understand your problem. Getting? I have told that calculate compound interest, calculate simple interest. So you should know what is compound interest, what is simple interest. Getting? So step 1 is, that is, understand the problem. Right? I'm telling you that these are the two numbers, and calculate GCD, that is common, greatest common divisor, or we call it as HCF. Okay, highest common factor. So I'm telling, take these two numbers and find out the GCD of it. So first of all, you should know what is GCD, isn't it? So first of all, what the concept GCD is, that is to be known. So step 1 is understand your problem. Getting? Second, analyze that problem. Okay, analyze means try to find out the overview step, means not the detailed step, but at least find out, okay, yes, we'll do it something like this. Okay, or I'll just try to write the solution for this in this way. Okay, not exactly the detailed step, but at least you'll get what? A overview process. Okay, generally if I do this way, I'll be able to get the solution. You're getting clear? Like as I said, like I told you to find out GCD of two numbers. So I'll just general make a step like I'll keep comparing the two numbers, and whichever is greater, from that I'll subtract the smaller, and I'll keep doing this till both the numbers don't become same. Okay, so I just got an general idea. Okay, how we'll find out? We'll keep comparing the numbers. Okay, and when both the numbers become same, we'll stop, and whichever is greater, from that I'll subtract the smaller one. Getting? So from the greater one, I'll subtract smaller one. I'll keep doing this till they don't become equal, and then I'll stop. And that is my answer. So I just got an overview. Okay, I'll do this way. Okay, so point one is understand the problem. Second is analyze your problem. Now third step is write the detailed steps of your analysis. What analysis you have done, now write the detailed steps. And the detailing, we call it as writing algorithms. Okay, now what is algorithm? We'll be discussing. Next topic is that only. What is algorithm, and then what are ways of writing algorithm. Okay, so we'll be writing algorithms or flowcharts. You can say algorithm or flowcharts gives the detailed sequence of finding the solution to the problem. So if you want to achieve the goal, then follow these detailed steps, and once we follow this detailed step, we'll get the solution. Getting? But these detailed steps are not the actual program. Okay, they are just the steps written in English like language, or you can say they are just the pictorial representation. Graphically, we have just shown the procedure, detailed procedure, but it is not a true program. Okay, so if your machine, that is your computer, is supposed to run it, you have to convert it into some program, and that is your last step. So fourth step is implementation. Okay, and after implementation, obviously testing and all you'll do. Testing means you'll check how much time your program is taking, how much memory your program is taking. The testing part is the last part, but the fourth step is converting that detailed steps which you have written in third step into a program. Getting? And once you write a program, then computer is able to run it. Means we are supposed to convert that steps into machine understandable form. Getting? Means how your computer will understand that step. And to make the steps understandable to computer, you have to convert it into actual program. And then how you'll write program? By selecting some programming languages. And obviously we have decided using which language? C. Isn't it? That is, for that only you have joined the course. So your main goal is to learn that C programming. So using the C language, this is example, but you can select your choice of language. You can select Python, you can select Java, you can select Go, you can select any language. Getting? There are evolutions of languages. Okay, so whichever language you want, using that programming language, you'll convert that detailed steps into program. And once you write program, now your computer is able to run it and give you the desired output. Getting? So I hope the steps are clear to you, right? So can quickly you people tell me the steps, what four I told you. The four steps are, first is understand the problem. Getting? First you understand what the problem is. Like I told, find out GCD of two numbers. So first understand what do you mean by GCD. I told you the problem is sort the given numbers. So sort the given number means first you have to understand what do you mean by sorting. Getting? Then I'm telling find out the solutions of a quadratic equation. I'm giving a quadratic equation ax square plus bx plus c, and I'm telling find the solution, roots. As it is quadratic, you will have two solutions. So find out the solutions of that so first you have to understand what is quadratic equation, then what are the formulas for finding out the roots, that is minus b plus or minus under root of b square minus 4ac upon 2a. You know that, clear? So first is understand the problem, getting? Second is analyze the problem. Analyze means just get an overview that I'll solve the problem by using these general procedures, getting? Not a detailed one, but at least you'll get what? An overview, which you do it in real life also. No? In real life also, many times you just give a superficial idea and then you start doing it in a detailed one, isn't it? Many times, like in real life also, yes, I'll do this, then I'll do this, then I'll do this. Okay, you just give an overview idea and then you actually start doing it in a detailed one. Okay, so first is clear to you. Second step, that is analyze the problem. Third is write the detailed steps for your analysis. Whatever analysis you have done, now write a proper detailed sequence of steps. And fourth is converting those detailed steps into actual program. That is called implementation. And once you do implementation, that is you convert that detailed steps into a program, you give the program to your machine will run it, it will give you the output. Okay? And at the end, obviously, you have to do testing also to find out whatever program you have written, is it really beneficial or not? Means sometimes it may happen for that only someone else is writing another program which is more faster than your program. So obviously that program will be more beneficial. Getting? So I hope these 4 steps are clear. Now you people can just respond me. What are that 4 steps? You can just tell me the steps so that we can quickly go through the slides. Okay. I need interaction from your side. Okay. Initially little bit theoretical. Once we come to C programming, it's very interesting. I'm sure you'll enjoy learning it. Getting? And all the trace outputs which I collected, I bring it from different forums and all, they will be really beneficial for you. Getting? I'm guaranteed whenever you'll face your interviews and all, they'll really help you. Okay?
Analyze, second step.
Second step is analysis.
Analyze.
Very good. Okay. Rishabh has written all the 4 steps. Okay. Very good. Understanding the problem. Okay. Analyzing the problem, then writing the detailed steps of it and converting into problem. You are really very intelligent people. Okay. Very good. Okay. Normally when I start teaching, I assume only my students are extraordinary intelligent, because if I don't assume that, I won't do my preparation that way. No? If I assume you all are dumb, like, so sure I'll also not prepare that way, isn't it? When I know all these students are very intelligent, I have to be ready. So I do my preparation also that way. Getting? Okay. So Rishabh and Astik, these all are these 2 students, I have seen them from their birth. Getting? So as much as your age, that much is my teaching experience. More than that, like, getting? More than that. I started in 1998. 1998 I started with teaching. That time you were not born also, my dear students. Getting? So anyways, so you are really intelligent students. Very quickly, Rishabh has given all 4 steps. Good. Okay. Prashita also wrote first step. Astik also wrote. Good. Now this, if you do this way interaction till the end of the course, I'm sure you'll learn many things. Like, okay. So quickly we'll go through these steps. Okay. See. So first step is understand the problem. So make sure the objective of the given problem. So what the problem is, that if you understand, good. Clear? Means first of all, if you have understood what the problem is, then only you will be able to write the detailed steps and you will be able to convert it into program. But if the problem is only not clear, it is meaningless. Getting? Then second, as I said, analyze the problem. Okay, so analyze means just finding out the overview, not the detail. But there can be many ways of finding out. Getting means for one problem only, there can be this one way, second way, third way. Like for GCD only, see, I told that ki keep comparing, and whichever is greater from that subtract the smaller one. This is one way, but there is another way also by getting remainders, dividing and then getting the remainders. That is called as Euclidean method. I'm sure somewhere in your mathematics you might have studied, or maybe in engineering you'll learn Euclidean method. So that is there. Many other ways are there. So there can be many different possibilities for getting the solution to the problem. So find different ways of solving problem, okay, and evaluate each of them. Evaluate means decide which one is better. Like this is solution 1, solution 2, solution 3. So you only have to use your intelligence to decide which solution is better. Getting? So here you don't get the detailed thing, just a broader view. So result is broad overview of sequence of operation, okay, that are to be carried out to solve your problem. Now in the third step, you are going to write the detailed steps, okay, that is developing the solution. Okay, now this detailed steps you can write using simple English called algorithm, or pictorial way, that is flow charts, or you can use pseudo representation. Pseudo representation means it looks like a program but not a program. Pseudo means false, no? Actually, pseudo term in English means what? False. So it is not a true program, but it looks like a program. So all three ways we are going to discuss in this chapter. I'll teach you simple English way, flowchart way, pseudo way. All I'll tell, because this all things are there in your academics. They in your engineering syllabus, they teach it too fast. That is different thing, but it is there. All three ways are there. Okay. So the sequence of operations are expanded to form a detailed step-by-step solution to your problem. And that thing only we call it as writing algorithms and flowcharts. Getting? Some people have this flowcharts and algorithm in their schools also. In school also you might have studied some IT papers. So in that also you have discussed all this. And then the last step is actually writing program. Because only writing flowcharts and algorithm won't suffice. Means this is not sufficient. Because your computer cannot understand that pictorial representation or that English sequence of steps. Means in English you have just written the sequence of step. Accept this, then compare this, or go to, if this is then go there, or otherwise stop and print the result. So in English you have written the sequence of step, detailed step, but computer cannot understand. So you have to convert that algorithm or flowchart into computer understandable form, and that is called as writing programs using some programming language. So conversion of detailed sequence of operation into a language that computer can understand, and that is conversion of algorithms to program using some programming language. So we are going to use C. So later once these first two chapters are over, then once we start with C and till the end of the course, you'll realize how these all algorithms and flowcharts will be converting into a program using which language? C language. Getting? But once you have a knowledge that you can convert using this in C language, you'll be able to do it using Python also. You'll be able to do it using Java also. Getting? Abundant of languages. Okay. Evolutions. I have presented myself one paper on evolutions of languages. Getting? Like starting from 1960, how the languages got evoluted. Like first language was in a procedural category, Fortran, non-procedural category, Lisp and Prolog. So starting from there till 2 years back, till 2 years back I did the evolution. I have done that complete evolution. I have presented one paper also on it. Okay. Now we will enter into this third step. We are going to now basically focus on this third step, that is writing the detailed steps of our problem And what are different ways of writing it? So I told three ways. One is algorithm using simple English. Second, pictorial way flowchart. And the third way is called as pseudocode. Okay, so I'll tell you about pseudo representations also. Don't worry. Okay? And many times in your engineering course, no, in your journals and all, they tell you to write pseudocodes. Many times they say just write pseudocodes. In interviews also, many times they'll say this is the problem, just quickly write the pseudocode. So pseudocode is more of like a program, but not a program. So we will come to that notation also. We'll come to the first way, that is using simple English. Okay. So we'll first discuss about what is algorithm. Okay, actually this word algorithm is coming from a Persian language. Now from Persian to Spanish it became algorithm. Then from Spanish to English it has become algorithm. Originally it is a Persian word. Okay, so in around 1700, when computer was also not invented, just imagine, in 1700, okay, now we are in 2021, so in around 1700, when computers were not invented, that time only how to find out the solution to the problem that was being developed. Okay, so a Persian mathematician, okay, Abu Zafar Muhammad ibn Musa al-Khwarizmi. I'm sure at one instance you might have not recalled the name. Okay, so Abu Zafar Muhammad ibn Musa al-Khwarizmi. He is a Persian mathematician. He was, okay. So Persian mathematician. I'm sure you might have heard about city Baghdad, Uzbekistan, country Uzbekistan. There one city Baghdad is there, and from there this person, okay. So he actually introduced the concept that if you want to find out the solution to any problem, write detailed steps of it. Okay, and once you follow that step, you'll achieve your goal. Getting? You have an obstacle, you have an hurdle, that is problem, and you want to achieve the goal of it. So to get that goal, you just write the sequence of steps and the detailed sequence of steps, but those steps are finite only, it cannot be infinite. So those detailed sequence of steps, when you write it and when you tell it to follow to someone, you can tell it to the computer, you can tell to some other person, or you yourself can follow it, and once you follow it, you'll get the desired result. Getting? You can say it is like a recipe, like mom follows recipe, isn't it? Nowadays mom, like previous generation moms were quite intelligent, they used to design their own recipes only. Nowadays they just follow YouTube and they just copy someone else's recipe and they try to implement it. Getting? Which you people are also going to do in your programming. Now as you're just first year student, you're going to find out the solutions of someone else only. Getting? Someone else solutions only, you're going to use it, you're just going to understand it and submit it in the college. But one stage will arise, okay, in your 4 years academic, where you will also start writing your own solutions. You understanding what I'm telling? Okay, so you can say what is an algorithm. So algorithm, Abu Zafar, he said, okay, if you want to find a solution to a problem, write detailed sequence of steps, and once we follow it, we'll get the desired result. Getting? So systematic definition, I'll come to it. Okay, see al-Khwarizmi, that al-Khwarizmi. So actually from that al-Khwarizmi, that algorithm and then algorithm, it became in English. Algebra is also actually derived from this Persian word only. Algebra, geometry and algebra we study. Okay, so the word algorithm comes from the name of a Persian mathematician, Abu Zafar Muhammad ibn Musa al-Khwarizmi. And he said that what? For finding out any solution to the problem, write detailed steps. Okay, so what is an algorithm? So it's a method which we can use to find out solution to a problem. Now as I'm using word computer because our subject is problem solving using computer. That time when he introduced, that time computers were also not there. Getting? But then they might have used it in some other field, like kings might have used for achieving some strategies, okay, in their kingdom. Getting? So it can be used in our day-to-day life also. We people will be using it in solving our computer problem. Okay, I'll give you the systematic definition now. What is an algorithm? You can say algorithm is a finite sequence of steps. Okay, they cannot be infinite. If it is infinite, then you can never reach to your goal, no? Isn't it? To achieve your goal, if the number of steps are infinite, it is impossible, no? You can never go to your, you can never overcome that obstacle. Getting? So it has to be finite. So it is a finite sequence of steps which, if followed, gives you the desired result. Now, who is going to follow? That depend. Obviously, we people are going to tell to whom to follow it, computer. But obvious, because our subject is problem solving using computer. So we will just write the sequence of step, convert these sequence of step into program and give the program to computer. Computer will do that. Isn't it? So you can say an algorithm is a finite sequence of instructions, okay, which if followed accomplishes a particular task. Whatever your goal is, task means your problem, okay, and to achieve that task you write a detailed sequence of steps, and these steps if followed give you the result. And this concept only we people, after so many years in 1900 when invention of computer started, so that concept from 1700, which that time kings might have used the strategies in if they want to follow it in their kingdom. Getting? For finding out the solution for so many things, like, getting, if there is a battle, if kings have to play a battle between someone else, so that time also they might have used this strategy, okay, of algorithm to find the solution for that, like, okay. So it is a method that can be used by computer for getting the solution of your problem. Whatever is your problem, to get the solution of that problem, you can use algorithm. Getting? Then I hope the definition is clear to you. Now we have to just see what are the good characteristics of an algorithm. And before telling you all this, just remember some characteristics which I'm telling need not be followed by your program. Means these are the characteristics of an algorithm, not necessary program. Means your program is following these characteristic is not necessary. Getting? It is to be followed only by algorithm. Okay. So what are that good characteristics or properties of an algorithm? The first one is, that is input. Okay, I'll tell you all this and then later I'm going to come back to you people. Okay, I'm going to ask you again all these characteristics. Input means what? So it is saying every algorithm should take 0 or more external input. External means we people are going to give. Okay, so every algorithm has to receive 0 or more external input. Like suppose you are told to calculate GCD of two numbers. So obviously that two numbers are to be given as input, isn't it? I'm telling you, check whether the number is odd or even. So what will be your input? That number. I'm telling, find out maximum of 3 numbers. So your input is that 3 numbers. Getting? But then you may say, like, you are saying 0 or more. Okay, so there can be algorithm which are not directly taking input externally. So indirectly, internally they might be taking. Okay, so internally means some output of one algorithm. Okay, any one algorithm output might be going as an input to some other algorithm. This is another algorithm 2. Okay, this is algorithm 1. But the result of that one algorithm is needed in the second. So this algorithm is not taking external input, it is internally taking. So therefore it is 0. From in this algorithm we are giving externally. Getting? But some algorithms may internally take, like, so when they are taking internally means indirectly it is given. Okay? So that is the first characteristic. So every algorithm receives what? 0 or more quantities as external input. And if there are 0 external input means they are taking internally input. So internal input means, I hope you got it, indirectly. Indirectly, like a output of one algorithm might be passed as an input to some other algorithm. Such cases also you will study it. I know now you are at a very early stage, at a learner stage, getting at a toddler level. But once you reach in second year, third year, then you will only start realizing. And whenever you start solving your problem, you will divide that problem into smaller problem. Then one problem output will be given as an input to another algorithm. Getting? Then second is output. Every algorithm should generate one or more output. One or more. Here I am not writing 0 or more. One or more. So when your algorithm is not producing only any output, now that output can be in a visible form, output can be some side effect, it can be indirectly some effect occurring somewhere, or it can be visible to you anyway. Either it is visible or it is giving some side effect, but it has to produce some output. Okay, so every algorithm produces one or more output. Getting? Like as I said, our algorithm was finding GCD of two numbers. So your answer has to be produced, no? That the GCD of that two number. Getting? I am saying check whether the number is odd or even. The output has to be produced, that whether it is odd or whether it is even. I am telling calculate factorial of a given number. I am giving a number and calculate factorial of it. Output has to be there. What? The answer of the given number. If the number is 5, answer should be 120. Number is 6, answer should be 720. So whatever is the number, its factorial I have to get as output. Getting? So, and if your algorithm is not producing output, it is meaningless. Throw it in a dustbin. There is no use of such algorithm which doesn't produce output. So at least one quantity is produced as a result. Getting? Then third is definiteness. Okay, at any point if it is not clear, please ask me. Clear? You can unmute and you can ask me, or in the chat window. Sometimes I don't see the chat window, so it is good practice. Unmute and directly ask me. Okay, at any point if it is not clear. Many more things to learn. Okay, so at initial stage only make it perfect, everything. Okay, so the third is definiteness. Now what do you mean by definiteness? Now this concept your program also has to follow. Means I said a few points algorithm follow, but the same characteristics your program will follow is not necessary. Okay, so you'll say what is that situation? I'm coming to it, but at least input your program also will follow, output also, definiteness also. Now what is definiteness? It says that when you are writing your algorithm using simple English like language, so when you are writing that sequence, finite sequence of steps, line by line you are writing the solution, detailed solution for your problem. Getting? Then all the steps should be clear and unambiguous. Unambiguous. Ambiguous means what? Ambiguous, this term in English you know it. Ambiguous means confusing. Confusing, or you can say there are multiple meanings for the same sentence. The sentence can be interpreted in different ways. Like in English, if I'm saying Mummy made Ram a pizza. Getting? So Mummy made Ram a pizza. So here it is confusing whether Mummy has made pizza for Ram or Mummy has made Ram's pizza only. Like he is participating in fancy dress and therefore she has made Ram only as a pizza, or for Ram she has made pizza, then you'll remove ambiguity na, by putting apostrophe and all, correct? So mummy made Ram a pizza is a confusing sentence, getting? Or little harder one I'm saying, in books selected information is given. Can anyone say, is it ambiguous? If I'm saying in books, selected information is given. Do you think it is an ambiguous sentence from your side? Is it a confusing sentence? No? Okay, it is ambiguous. So why you think it is ambiguous? Let's see. I know you all are intelligent. How you read it? Clear? In books, okay, if I'm pausing here, in books, selected information is given. Okay, he's saying no books give selected information. Okay, that's what I'm saying. How you're reading that sentence? In books, I'm pausing here. In books, and then I'm saying selected information is given. Means the inside that book, the information is selected. But if I read it this way, in books selected, information is given. So what is selected? Books are selected and then inside that information is given. So where I take pause while reading the sentence, accordingly the interpretation is different. See, in books, I'm taking pause here only, in books, and then I'm saying selected information. So the information is selected, isn't it? And if I say in books selected, and then I'm taking pause, so in that books are selected and in that information is given. So whether the information is selected or whether books are selected, that is confusing, isn't it? So you can interpret that way कि books are selected and then in that information, or books are not selected, information is selected. Getting? So how you read it, it is confusing. So same way in your algorithms also, when you write your detailed steps for your problem, each and every step which you write should be clear. It should be unambiguous. Getting? It should not be a confusing statement. So each instruction is clear and unambiguous. I'll give you an example that the example which I gave was quite difficult, but it was related to real life. In programming terminology, getting? This is a very common example. See, add phi to x or y. This is not a clear statement. It is not telling fix कि add phi to x or y. It is saying add phi to x or y is not valid. You either tell x or y. Means either you give the condition कि if this is the condition, then add in x. Otherwise, then add in y. Getting? Means you can tell that कि if this condition is satisfied, then add in x. And if it fails, then add in y. But you're not making it clear. You're just telling it as what? Add phi in x or y. Add in any one you add, x or y. Is not a clear sentence. Getting? And suppose I'm writing divide phi by 0. Means if your denominator comes 0, so your answer is going to be indefinite. So such sentences also should not be there. Means in your program, you should check the denominator first. If it is coming out to be 0, you should not do only that division operation. Getting clear? So always check that each and every instruction which you write is clear and ambiguous, unambiguous. Okay. Then the next characteristic, that is finiteness. Okay, now what do you mean by finiteness? So finiteness says that if whatever sequence of steps you have written, they should eventually, after some time, let it take some time, okay, but after some time it should halt or it should terminate. Getting? Means it is never stopping. Then we say it is not finite. Okay, so whatever algorithms you write, sequence of steps, and if you trace them, you are tracing it step by step, you are checking how it will go, then this, and while tracing you are realizing that it's never getting halted. Okay, so we'll say it is not finite, but not necessarily your program will follow this characteristic, because there can be a program which is not finite. Means you can write a program which never stops. There are such programs. Very common example, I'm sure you will be able to give that example. So this is an exception to program. What I'm saying, कि programs will follow finiteness is not necessary. When you write algorithm using simple English, you take care that कि all your steps what you have written will terminate at some time. They are going to halt at some time. Okay, so if we trace out the instructions of an algorithm by paper pencil, manually you're checking that if I give this as an input, I am giving some sample input, I'll give some sample input, and then on that input I'll try to check how this step is running, how this step or it is coming back. So when I follow that sequence of steps, so at some point your algorithm is going to halt. Then we'll say it is following finiteness. Okay, so if we trace out the instructions of an algorithm, then for all cases the algorithm terminate after a finite number of steps. Getting? And if it is not terminating, means we'll say it is not following finiteness property. Getting? But programs are excused to it. As I said, not necessarily your actual programs which your machine is going to run, they will follow this finiteness property. You understanding? Clear? Best example is, can you think about any one example in your computer, okay, which is not following finiteness property? No, I'm sure you'll be able to guess it. Any one program which you have seen in your computer which is indefinite, means indefinite, you can say infinite, it's running, it never stops. Calculator. Okay, but you can stop it. If you click on the cross sign, it stops. Right, no? Clear? I hope I rectified you. Calculator you start, then you do calculations and all, but once you click on cross sign, it goes. System UI. System UI, exactly which in that category? Who? The base, like the core on which your entire system is running. He's going to nearby is going to an proper example, Rishabh. System UI telling, but which program come under that category? Or antivirus is also an example. Yes, you can say once you install antivirus, it is continuously in the memory. Very good, very good. You people, I said, no, you're really smart people. Huh? You're really smart. Okay, antivirus you can say, because once you install antivirus, it is always resident and it is continuously in background. It's a background process, but still it is it's called as a daemon process. Okay, it keeps running in the background and continuously checking and gives you alert. Getting? And it will stop only when your machine stop. So the similar concept, antivirus, similar Rishabh is trying to tell. Which program based on which your entire computer system is running, means who is the core of your computer. Afterwards you start everything, notepad, wordpad, or Microsoft Word, Excel, you start your games, everything. But all these are based on what? CPU is just your CPU is not a program. CPU is a hardware entity. CPU is a hardware entity. Its work is to just execute the instructions. Whatever instructions are given to it, it will run it. But CPU is a hardware entity. Okay, CPU is like a, you can say, it's a donkey sort of thing. Okay, it will just keep doing work. Donkey, you cannot say, uh, donkey is also having brain, no? Like, so it will keep doing the work. Dumbs are different thing. Okay, donkey also does work, no? Right? But it keeps doing the work continuously. So CPU is also same thing. You keep giving instructions and it will keep running the instruction. That's all. But the instructions are given by the programs, no? Our program. Which is that program based on it? I just want to find out from you people, and I'm sure you'll be able to give the answer. Like antivirus, same like antivirus which you said. Before that, task manager. Task manager just gives the list of, uh, see how one by one you people are answering. Getting? You started thinking. Thinking process should never stop, and that is the speciality of humans. No, humans think, and that's the reason we are superpower. No, we can do everything. Why? Because we have that thinking ability. But task manager is just a utility which tells you who all are running, which programs are running. Means your MySQL is running, your Oracle is running, so many programs are running. So it just gives a list. Rishabh should answer. Your system. First, tell me, once you start your computer, okay, so which is the first program which will start, and after that, then our work start? No? Any guesses? The first program which will start, and then after that, we are ready to do the work, and then our work will start. OS, very good. Clear? That is your operating system. That's what I was trying to get from Rishabh. He told that. Okay. OS. OS means your operating system. Very good. And operating system is the first program, no, which come into your system. Once you power on, okay, all the hardware test and all takes place, and then that bootstrap program is there. Okay, bootstrap program, a program which will make your computer to make it eligible your computer to start with the activity. So that bootstrap program will bring your OS in the memory, and once your OS come in the memory, now your OS is ready for you to give you the service. Now OS is saying, now I have come in the memory, now I am ready to give you service. Then we people start taking service from operating system. Get it? Then all these programs start. No? You start your antiviruses and all that things. Okay. So I hope you got it. OS is the first program, and OS never goes from your memory. It is infinite remaining in memory till you don't power off. Now, obviously, once you power off, you stop giving the power to the system, then it will go. But till the power is not off, it is infinite running in the memory, and its job is to give service to our program. Getting? OS is like a service provider. You will be learning specialized paper only. You will have a separate paper in your academics in which you will be learning about OS and the design of OS, functionality of OS. Okay, see, the best example you people gave me, operating system is exceptional. It is made to run infinitely till the power is not off. So OS is a program which doesn't follow this characteristic. Getting? And quickly, the last characteristic I'll tell you, that is effectiveness. Okay? Now, effectiveness means you write your steps of algorithm in such basic way that you should be able to evaluate on your own using paper pencil. Now you have written the steps, okay. Like simple algorithm is for addition of two numbers, so you have written read a, read b, then add a to b, store it in c, then print c, and then stop. Like where you have written the sequence. Now you are taking some sample input, okay, some sample input, and on that you are trying to check these steps, whether these all steps are going fine or no. Getting? So effectiveness means what? You should write the steps of your algorithm in such basic way that if you try to apply it on some sample input manually, not to the computer. I'm not telling it to evaluate it to the computer. Computer can evaluate any complicated thing. Getting? And that's the reason computers were invented. No? The work which was tiring for us, we introduced computer, and now we are telling computer you do it. Like, getting? Because to do this activity on my own, it is a tiring activity. Getting? So the steps which you write should be so basic, getting, that you also will be able to solve it using paper pencil on some sample input. Getting? But again, this is exception to program. Not necessarily your program will be effectiveness. Getting? I'll give you an example. Like suppose I'm telling you to multiply two 2 by 2 matrices. I'm sure in 12th you have studied matrices and all, isn't it? So if I'm having a 2 by 2 matrix and I'm telling multiply it, okay, you'll do it quite easy. Quickly you'll do. 3 by 3 also you'll do. Paper pencil. I'm telling about paper pencil. Okay? Till 3 by 3 is okay. It will take little more time, but you'll do it by paper pencil, by putting sample. But as the order of matrix go on increasing, I'm telling now 4 by 4, 5 by 5, effectiveness goes on decreasing. You cannot do it by paper pencil. You understanding? Clear? So, but computer won't complain. Na? Computer won't say कि I can do multiplication of two matrices only till 5 order, only till 6. Any order, computer is going to do it. Getting? But you people, at least when you are writing the steps of your algorithm, write in such basic way that if you give some sample input, and on that sample input by using paper pencil you are trying to apply the steps, you should be also able to do it. At least for some sample input, you should be able to do the operations. Getting? There are exceptions, no? Like common human being cannot do it till higher order. No? 3 by 3 is okay, but as 4 by 4, 5 by 5, 6 by 6, we cannot do it. Exceptions are there. Getting? Exceptions like Shakuntala Devi. Before that, a great mathematician, Tirthaji Maharaj. Getting? We should be proud that it is origin of maths is again India only. Getting? So Jagadguru Tirthaji Maharaj, he was extraordinary scholar in maths, and manually he used to do it. Shakuntala Devi also, I'm sure you might have watched her movie and then you might have realized the power of maths. Like, okay, but they are exceptions. No? Common men, all people cannot do it, no? That quickly. Okay, so when you write your algorithm, see to it, at least for some sample input, you should be able to perform those steps. Getting? And we will be doing it. Like in your data structures also, later when you'll study data structure, they'll teach you different sorting methods. So when they'll teach you sorting method, they'll give you some sample numbers. Then they'll say sort these numbers using this method. So you'll apply that algorithm on that numbers, and manually you'll try to apply that steps and find out the solution for it. Okay? So effectiveness means each instruction must be very basic. Means you write it in a very simpler way. Don't write it too complicated. Okay? Means don't try to do 3-4 operations in one equation only. Okay? So each instruction must be very basic so that it can be carried out by humans using paper and pencil. Just an example I've given. Adding two whole numbers is effective. Means I'm just telling how to understand effectiveness. So if two whole numbers are given, I am telling you to add it. It's okay, you can do it. But if there are two real numbers, floating point numbers, two big recurring number, okay, 2.163211592, very big recurring, and then I'm telling add these two floating point number. Getting it won't be that fast using paper pencil. So you can say it is not what effective operation.